At MIT, I got computer vision software that was supposed to track my face. It didn't work until I put on this white mask. I'm thinking, all right, what's going on here? Is it the lighting conditions? Is it the angle at which I'm looking at the camera, or is there something more? That's when I started looking into issues of bias that can creep into technology.
Our ideas about technology that we think are normal are actually ideas that come from a very small and homogeneous group of people.
Vast amounts of data at incredible speeds.
Everybody has unconscious biases, and people embed their own biases into technology.
This kid got stopped as a result of facial recognition misidentification, and then used that as justification to search you. This is an innocent child.
Racism is becoming mechanized.
Systemic issues are only going to be hardwired into new technologies.
It's not just face classification, it's any data-centric technology.
Every day, we are all being scored.
Who gets hired? Who gets housing?
I am making predictions for your life right now.
The people who own the code deploy it on other people, and there is no accountability.
Management analytic towers wanted to install the facial recognition software. Pretty much turn this place into Fort Knox.
The technology is being rapidly adopted, and there are no safeguards.
We are socially controlled in a way that we don't see.
Technology that analyzes faces could be biased, but the company is pushing it anyway.
What demographic is it most effective on?
White men.
Show me that it's going to be fair, that it's legal, before you put it out. That's what we don't have yet.
It's going to take people coming together, striving for justice in this age of automation.
So, what do you guys think about the video that you saw now? Anybody working in ethical AI here? Anybody trying to study about it, AI ethics, apart from Susanna and the past AI ethics students? We would like to hear from you. So now I will be moving on to the fairness analyzer presentation that I have. So I'm Yashaswini Viswanath, and I am, you can call me Yash, and I'm the host of Weekly Wednesday. And today I am giving a talk on the fairness analyzer.
Yes, you are on mute.
Oh, sorry about that. So What is fairness and why does fairness matter to us? I would like to know your thoughts if you have thought about this before, about AI ethics, ethical AI, and about fairness in AI. Fairness terms that we need to understand are protected attribute, privilege protected attribute, group fairness, individual fairness, fairness metric, favorable label. We have these various fairness terms. When we talk about ethical AI, we generally talk about the cognitive biases and how we qualitatively look at them. Here is a quantitative outlook on how we can use mathematical calculation to analyze fairness. How to measure fairness? So here are some group fairness metrics. We have the statistical parity difference, disparate impact, equal opportunity difference. These are the different metrics using which we can analyze the fairness of an ML model that we have. If we see here, we have a machine learning pipeline and we have the different stages in which we can introduce the fairness analyzer. We can start off with the dataset metric. Then when we have the pre-processing algorithm and in the in-processing algorithm, we can introduce mitigation, bias mitigation measures, and we can have the fairness analyzed and the bias mitigated. So what is statistical parity difference? It is computed as the difference of the rate of favorable outcomes received by the underprivileged group to the privileged group. So when we talk about the underprivileged group and the privileged group, here we could mean based on age, based on gender. And when we have the statistical parity between the unprivileged and the privileged groups, we say that the fairness is good when the difference is less. We have the equal opportunity difference, where we have the difference between the desirable outcome. We should have the same chance of desirable outcome for both the classes. So here we are talking about binary classification in supervised algorithms, where we have two classes and we have the outcomes. For example, a credit score that is computed, and people are decided to give a loan or not to be given a loan based on that. Disparate impact. So here we have the ratio of the favorable outcome for the underprivileged group to the privileged group. These are metrics that have been defined by researchers. We have the average odds difference, and similarly we'll have the tail index. So the credit goes to IBM Fairness, AI Fairness Toolkit, and I would like to show a demo of the toolkit. Here is the sample data set that we can take. We have three different data sets, one from Publica. Last time, Susanna had talked about it, and she had shown how we can access these public data sets, civil data sets that are available online. This is by IBM Research, and here we can choose a data set to see the demo of how we can analyze fairness. So I've selected German credits.
You are unable to see that screen, I think. Yeah.
Okay.
It's in PPT screen. Sorry.
Oh, okay. Thank you. Thank you, Rajana. So Here, this is the AI Fairness 360 demo that we have today. And we have different data sets that we can use for this demo. And we can see how we can analyze fairness in the ML model that we have. So I talked about the ProPublica data set, and here is a German credit scoring data set and an adult census income. So I've chosen German credit scoring. Once we go here, there's we check for the bias metrics. The tool checks for the bias metrics and the statistical parity difference, the equal opportunity difference, the average odd difference, the disparate impact, and the tail index that we saw that time are computed here and shown for the protected attribute sex, where the privileged group is male and the unprivileged group is female. And if we see this German credit scoring, we have this a disparity where the unprivileged group is the younger group, the privileged group is the older group, and they have an advantage over it. So here we see that 4 out of 5 metrics, we see that there is bias. How do we know what are these metrics and what these values mean? So in the PPT, I just explained each one of them. And here, if we go, we have what fairness means. How do we compute fairness? And based on that, we get the information. So once we have the bias metrics, and when we see that there is bias, there is no bias, or how much is the bias, we can move to the next step. That is, we can choose a bias mitigation algorithm. Here are 3 algorithms that are there: reweighing, optimized pre-processing, and adversarial debiasing. And I have one more, that is a reject option-based classification. If you see here, each of these algorithms are used at different stages. We have the reweighing and the optimized pre-processing at the data gathering stage, the data cleaning stage, where we prep the data for the classification. We have the adversarial debiasing, which happens at the classification state, and we have the reject option-based classification, which happens at the prediction stage. So once we choose one of these methods, we have the comparison of the original and the mitigated results, where we have the old classification model and the new classification model, and how we are pairing with the fairness. How are we doing? Are we doing better? Are we doing worse? Based on the different indices. So this is a small demo that I had for the responsible AI and AI Fairness 360. Here, if we see, once I have chosen reject option-based classification, and I have got these results. And next, I have chosen one of the other techniques, that is reweighing, and I have got these results. So if we see, we need to make a decision, which of these algorithms, which of these methods are best for us, best for our data set, for the problem that we are solving, for the organization that we are in, for each of the industry and for each of the business problem, the bias mitigation strategies are different. So this was a demo on a fairness analyzer bias mitigator tool. So generally we hear a lot of concepts around it, but there are tools and techniques that are available which mathematically show that. And also we have a class by Susanna, and we have an AI ethics inclusive class by Susanna. And I would like to ask Susanna to talk about her class, what we will be studying, and how we will be going about that. Susanna? Okay. Um, here is the class AI Ethics, Responsible AI, Inclusive AI class by Business School of AI, and here we learn about AI ethics principles. So fairness analyzer is just a part of it, and if you want to understand what is AI ethics and how do we apply it for the organization, how do we bring in this fairness in AI algorithms so that we have better systems. This is a nice course that is there. And if you click on enrollment, you get you have a AI ethics webinar that you can get by Sudha. And this time we have Renee Cummings, who is a world-renowned AI ethicist and data activist. And she will be taking a master class. Susanna, are you there?
Hi, Yash. Sorry, I was in another call.
Hi, Susanna. So I had this talk about fairness analyzer. I used IBM Fairness 360 and I did a demo of German scoring index. So Susanna, we would like to hear about the class that's coming up in fall. I just showed them the place where they can get the webinar and also the course and Renee Cummings and all of that. Susanna, could you just tell us what we can expect in the course, what we can learn there?
I'm going to be talking about inclusive AI and what does that mean in terms of model building, in terms of teams, in terms of bringing diversity, not only in teams, but also in how in the different disciplines and as well as in collaboration. So that's what I will be talking about in terms of inclusive AI. If anyone has any questions on that, yeah, you can, you can start, collecting them and then we will discuss that in the class.
Thank you, Susanna.